Hi guys, welcome to video number 19 for Flip Geometry. This is going to be all about the surface area of a cone. So the cone, well, we're usually familiar with it in this direction, maybe holding some ice cream or something. So this is sadly without the ice cream. If you imagine it's made up of one circular base here, and then all around that base comes up in one smooth lateral side up to a point here. So if you imagine this drawn here, the dashed line representing the other side of that base that you can't quite see, if we take that apart, what's going to happen is there's going to be a circle. So this circle represents our base there. So essentially this is this. And what I've done is cut one from the very vertex here down to the edge of the circle and opened it up. And if I open that up, what I have is the vertex, and that's up here. Maybe if I flip that around, it'll be a little bit easier to see. So why don't I draw it where, if this is that vertex here, I've got the two sides and then a really wide sort of rounded bottom there. So if I cut that, it opens up to a piece like this. Now, it almost looks like a piece of pizza. So let's start thinking about how we would find the surface area of this shape. Well, it follows our usual pattern here. We have one base area. In this case, we have a circle. So we have that the area of that circle is going to simply be based on pi r squared. Great, so we've got that the area is pi r squared. Maybe I'll write it down here because I need that space in just a moment. So if the area is pi r squared, that's great. We've got that. Well, what would we need? We would just need to know the radius here. So that's the only thing I would need in order to determine that. So we can now write the base area here. So our surface area is going to be equal to our base area, which is simply one circle, pi r squared, plus the area of the lateral side. In other words, plus the area of this thing. Now, let's talk about that lateral side for a second here, because it almost looks like a triangle. Let's think about what we know about it. Now, the distance from the side of the triangle, or the side of the cone here, up to the vertex. Do you remember when we were talking about the square pyramid in the last video, and I said, we're going to talk about something called slant height, which was little l, from the side of the base up to the vertex. The same thing is happening in our cone here. We're going to think about from the side of the circle, the side of the base, up to the vertex. Because it's on a slant, we're going to indicate that as slant height. So we're going to use that same indicator, that little L, to indicate a distance from here to here. So that L goes from the side of the circle up. So if you imagine this was exploded and opened up here, the distance from here to here is that slant height. We've got that distance there. That means that this is the slant height, and in fact, if you imagine, this is like a radius of slant height. So in other words, from this point all the way along this line is L, is this little L. So if I draw it right down the middle here, let me show you something. If I've got that and I'm indicating that as L, it almost looks like the little h on a triangle. It almost looks that way. So I'm going to leave it at that point. I'm going to erase this just so I don't cause any confusion. But that is where L is. You can imagine that's it there. It's also represented here. Anywhere along this line, which is the same as, of course, our circumference, just in case you didn't guess that, the same as our circumference here, all the way along there, from there to that vertex is our L. Now, I kind of just gave it away a second ago, but our distance along here, if you imagine we took that and we took it apart, this whole distance represents the circumference of the base. So that line is C. So, in terms of figuring out the area of this, it looks like a triangle, and in fact, we're going to use the triangle area formula. Now, usually we would say, little b times little h all divided by 2. In this case, well, usually our little b is down here somewhere on the base. We actually have c. So instead of little b, I'm going to change that. Well, here, why don't I rewrite it over here? We've got that. This was our original. Area is little b times little h divided by 2. So instead of doing that, what I'm going to write is that the area of this shape, which is similar to a triangle, is going to follow a similar pattern here. We're going to say that its base this time is its circumference, and that that little h is now that L, and it's all going to be divided by 2. So we've got this as a formula for the area inside of our lateral shape here, this funny looking pizza slice. Okay, so that's going to represent the area inside there. Now, let's add that to our formula here, because remember the formula has to be for the entire cone. We've already got the circular base represented here as pi r squared. Let's add this piece to it. So we're going to simply do this. We're going to say plus circumference times the slant height divided by 2. Now, we know that we can calculate circumference in 2 different ways. We can calculate circumference as the diameter multiplied by pi, or 2 times the radius times pi. So I'm actually going to substitute that in this case, and you'll see why in just a second. So I'm going to rewrite this, and I'm going to say pi r squared. Of course, that's not going to change. And instead of c, I'm going to write it as the formula for circumference, which is 2 times pi times r. Then I'm going to multiply that by the slant height, which is L. Okay? And then all of that is going to be divided by 2. And now you might see it. There's a 2 in the numerator and the 2 in the denominator. Those can be canceled because they can, 2 over 2, that's 1 there. So in the end, our cone surface area formula ends up as pi r squared plus pi times the radius times the slant height. And that is the formula for the surface area of a cone.